Alright guys, so now let's look at one type of chemical bond that exists. So that's called ionic bonds. Ionic bonds are formed between two ions by the transfer of electrons. So one atom is going to give electron and another atom is going to gain electrons. In the process you form something called ions that are charged particles. I know you've read about those before. And my hope is that in this presentation you'll really understand what are ions. So here's an example. Now potassium is group 1 element, so it has 1 electron in its last shell. The fluorine is group 17 element. It has 7 electrons in its last shell, and therefore we get an electron dot diagram like the one you see on the screen. Now potassium wants to lose 1 electron to look like the closest noble gas and become stable and only have 8 in its last shell. Meanwhile, fluorine has 7 in its last shell and it wants to gain 1 more electron to look like the closest noble gas. So that's exactly what happens. The potassium gives up its 1 electron to fluorine. But in the process, potassium becomes charged, and so does fluorine. Potassium now has a +1 charge because it lost 1 electron, and fluorine has a -1 charge because it gained 1 electron. Now, because of these things, potassium and fluorine charged are called ions. They're the smallest particles, and potassium has become an ion, and fluorine has also become an ion. Now, this attraction of positive and negatively charged ions is what an ionic bond is. So an ionic bond is just that attraction that brings the potassium and fluorine together. This is, by the way, any ion that is positively charged is called a cation, and any ion that's negatively charged is called anion. And the way you can remember this is if you look at the T in cation, that looks like the positive sign. So you can remember cation are the positively charged ions. Now let me explain to you why potassium became positive and fluorine became negative. So potassium used to have 19 protons and 19 electrons for a neutral charge. But now potassium has 19 protons and only 18 electrons, and that makes it a +1 charge. Fluorine, on the other hand, used to have 9 protons and 9 electrons for a neutral charge, but now it gained a negative electron and it became 9 protons and 10 electrons for a charge of -1. Now, how do you name an ionic compound? You put the positive ion first, and then you put the negative ion, and then you change the ending to "ide." So potassium is a positive ion, and fluorine's a negative ion. You change the ending to "ide." This becomes potassium fluoride. Now let's see if you can try this. So in your notebook, I want you to show how sodium and chlorine exchange electrons to form an ionic bond. Here are the couple of questions I want you to answer. Go ahead at this point, press pause in the video and go to your notebook and see if you can answer these 5 questions. The numbering is incorrect, but these 5 questions in your notebook. Draw an electron dot diagram, draw an arrow to show how the electrons will move, what charges will they form, which is the cation, which is the anion, and what will be the name of the compound. Alright, now let's see if you guys got the correct answer. So sodium has 1 valence electron and chlorine has 7 valence electrons. So sodium will give up its 1 valence electron to chlorine, and sodium will become a +1 charge and chlorine will become a -1 charge, and that's what will attract the two of them. Sodium is an anion, it's a positively charged ion, and chlorine is a cation, I'm sorry, I'll take that back. Sodium is a cation, positively charged ion, and chlorine is an anion, negatively charged ion. And you can see that they get attracted to each other. That's what makes an ionic bond, the attraction between a positively charged ion and a negatively charged ion. Here's another way to think about it. You can think of ionic bonds as one big greedy thief dogs. They come in and they snatch the bone of the weaker dog, and because the stronger dog now has the weaker dog's bone, he kind of hangs out around that dog to make sure and hopefully at some point get it back. So there's a give or take. There's a exchange of electrons, a mutual exchange of electrons that happens. Now I know you can probably watch this animation for the remainder of the class period, but let's move on and look at some other things. So sodium again used to be 11 protons, 11 electrons, and its charge used to be 0. But it just gave up 1 electron, so now it has 11 protons and 10 electrons, and that's how it became a +1 charge. Chlorine is 17 protons and now 18 electrons, and that's why it became a -1 charge, and its name is sodium chloride, your table salt that you deal with every single day. And this is one of the reasons why ionic compounds are very brittle. They have very crystalline kind of structure. Because basically an ionic bond is just positive, negative, positive, negative, positive, negative charges put together. So atoms that are either positively charged or negatively charged put together in a very rigid structure. At some point we're going to do, very soon, in a couple of days, we'll do a lab about a lot of these behaviors of ionic compounds and covalent compounds. All right, let's see if you can try one more example. So in your notebook, I would like you to show how potassium and chlorine exchange electrons to form an ionic bond. Again, the numbering is off, but go ahead and press pause and see if you can answer these 5 questions. All right, if you're finished, go ahead, call me over. I'd like to see how you did. And based on how you did, I can either help you or I can give you the next step, a little more challenging example. All right, so here's a little more complicated example. Calcium that has 2 valence electrons and phosphorus that has 5 valence electrons. So in this case, it's not an even number of electrons. So what happens is calcium gives up its 2 electrons and becomes +2. But that doesn't solve phosphorus's problem. It still needs 1 more electron. So we add another calcium. But now this phosphorus is all set, but calcium, the second calcium atom, still has 1 electron to give up. So we add another phosphorus. Now when you add another phosphorus, you still need 2 more electrons. So you add another calcium, and these 2 electrons go back to phosphorus, and that's how you finish the ionic bond. So it's not always one-to-one. I wanted to show you an example that's a slightly difficult example where you have to keep on adding calcium and phosphorus, keep on adding the atoms until you can get all the electrons accounted for. This formula becomes Ca3P2 because there are 3 calcium atoms and 2 phosphorus atoms. All right. Next time, tomorrow, we'll take a look at covalent bonds. But that's it for now. So make sure you guys pick up your assignment, your next task, and put your iPads away. And I'll see you guys tomorrow.